We're starting off with a graph. And let me start off by saying you're not going to have to draw this graph here that has 1, 2, 3, 4, 5, 6, 7 turns, right? But we're using this to explain what multiplicity is about and what we're trying to do. If you look at this graph, the red dots show where we're hitting the x line, and that's the roots of your equation, or your zeros of your equation. And as you can see, at some of these red dots, it crosses across that x line, but at other dots, it touches and it turns. So the first two dots, for example, cross, and then the next dot touches and turns. Then it crosses, and the last dot, the graph touches and turns. The good news is we can use multiplicity, which is how many times a root shows up in factored form, to determine when it crosses and when it touches and turns. So that's what this video is about today. So we're going to use this x to the cube, x minus 1 squared, x minus 2. And we're going to do a side note about roots, right? A root, or let me add this word here, or a zero, right, of an equation makes it 0, and that's where it crosses the x line. So for this one, x squared minus 2x plus 1, I'm telling you that 1 is a root, and we can check that. 1 squared is 1, minus 2 times 1 is minus 2 plus 1, that gives me 0. Well, if I have a root, I can divide or factor out x minus the root. So here I could divide out x minus 1 or factor out x minus 1. So here, back to here, this is already in factored form where we can see the roots. So x to the cube, x minus 1 squared, x minus 2. So our roots, you see, are 1 and 2, but the first one is 0, because x to the cube is x minus 0 to the cube. And because it's to the cube, that 0 shows up 3 times. The 1 is inside of a square, so the 1 shows up twice. And the 2 is by itself, so it shows up once, right? I could easily add a 1 right there. It shows up once in multiplication. So what is multiplicity? Now, there was a movie back then by Michael Keaton called Multiplicity, where they cloned him. It was in the 90s, and to perform several tasks. The problem they encountered is that each clone had a different personality. It was a comedy. But this one here, your numbers are going to stay the same numbers, but it's kind of the same idea. The number shows up more than once in the multiplication in factored form of the roots. So if we say 0 shows up 3 times, we say that 0 has a multiplicity of 3. If 1 shows up twice, it has a multiplicity of 2. And if 2 shows up once, it has a multiplicity of 1. Now, this is where it gets interesting. The multiplicity, how many times it shows up, whether it's odd or even, gives your graph a different behavior. In our case, we're going to see that 0 has multiplicity of 3. That is odd. Therefore, the graph crosses at 0, right, at the root. It just crossed. The same way the last one, 2, has a multiplicity of 1, that's also odd, right? So that crosses at 2, because that was the root, was 2, but the multiplicity was 1, which is odd, okay? So now we know that at 0 and 2, the graph will cross, and then here it's even. At 1, it shows up twice, and when it's even, it touches and turns. It touches and turns. This is at 1. So now we can draw this, right? If we know a little bit about graphs, this x to the cube times x squared times x is x to the 6, right? It's going to give us an x to the 6, which starts at the top and finishes at the top. So we know it's going to start at the top. So a graph, let me see if I can do this graph in a different color. Let's pick blue. Our graph here is going to start at the top, cross at 0, touch and turn at 1, and cross at 2. So it starts and it finishes like this. It crosses at 0. It touches and turns at 1. Sorry, it touches and turns right there. And it crosses at 2. Okay? So that is a general look, right? Not an exact look. Now, Professor David Simon on Simon Says Math YouTube talked about for a while multiplicity as part of a bigger lesson, a much bigger lesson on graphing and graphing graphs, if you would like to go further into this topic. Thank you very much. This was multiplicity and how it helps us know if we're crossing the graph or